In this random experiment, we are going to toss a coin 3 times, and we will also aim at representing the results using a tree diagram and then representing the sample space for the sequence of outcomes we will get from the experiment. When we toss a coin, we can get 2 results. As stated above, in the upper right corner, we can get heads or tails. We won't worry about the probabilities, we just want to represent the results in the tree diagram. So, for the first toss of the coin, we can get these 2 outcomes. When we toss the coin a second time, we know that the outcomes will also be heads or tails, no matter what the outcomes from the previous toss were. So, in the second toss of the coin, we will get those results as well. Finally, when we toss the coin for a third time, we will get heads or tails as the outcome, no matter the previous results. So, we have represented all the possible outcomes in the tree diagram, and now, if we want to compile the sequence, we have in the first possible outcome 3 heads, a sequence of 3 heads, and then heads, heads, tails, and so on. We can compile all the sequences. We have 8 different sequences, which are the 8 possible outcomes for the random experiment of tossing a coin 3 times. Finally, the last sequence is a sequence of 3 tails. Now, if we want to represent all these outcomes in a sample space, what we need to do is to use, for example, a Venn diagram, and we can represent the set of outcomes for this experiment, and then we just need to place the sequences within the sample space. This way, we can build a tree diagram and the sample space for a random experiment.